happened when this incident broke out. They had to actually, it wiped out 3 servers. They had to reboot the entire system. And she found that the player behavior was very, very true to life. You had people who freaked out. They were told to stay. They were told to honor quarantine and not spread it, but they freaked out and they ran anyway. You had people who did that deliberately, thinking, well, if I'm dying, I'm taking everyone with me. This is how people think, okay? You had one guy who decided it was his job to be the prophet of doom, and he spent the rest of his brief avatar life in this town square proclaiming the end of days. And, you had people who rushed in to help. You had people who were like not even in that level, but heard something really exciting was going on. They were like the reporters who rushed into the war zone to say, let me see what's going on. Oh no, I'm dead. So you have to take these things into account when you do mathematical models, is my point. So where am I now when it comes to calculus? It's funny, I think people, because I wrote this book about calculus, like occasionally I get people thinking, well, so now you're like this whiz, right? And you're going to like ace the AP, SAT exam. No. When I say I was doing baby calculus, I mean I was doing baby calculus. And I would say that my level is still very much at the C. Jane run, maybe moving to the next level of calculus. It certainly is not the level that they do at the Perimeter Institute, nowhere near. That's not the point. When people ask me what I gained out of this exercise, it wasn't, I taught myself calculus, yay. I gained an appreciation for why math was important. It gave me insights into the stories that I continue to write. It made me a better science writer. It helped me see connections in the world. It helped me understand why my husband thinks weird things the way he does. So the real value that came out of that was this idea that I didn't have to ace the AP exam. I think that particularly when we're young, we get caught up in the idea of having to always get the 100%. And it really should be about the joy of learning new things. And I am still learning. I'm still learning more about math. Every time I go back and do a calculus problem, I see something new in it. Every time I write a physics story about something that I thought I understood perfectly and I start looking into the math now because I'm no longer afraid of it, I gain a little bit of extra insight. It's all part of this wonderful learning process. And that is, I think, something that I didn't have when I was growing up. And it raises, I think, the other important part about math phobia that I want to talk about. Because I'm not really here tonight to teach you calculus. I want to give you an idea of why it's important, what it's about, what it's good for. But ultimately, it all comes down to, why do I need to know this stuff? And I guess that would be, my message to the students out there in particular. Whenever I talk to young people and they ask me that question, I get where they're coming from, because I was that student. I was the person standing there saying, when am I ever going to use this? I'm never going to use this. And maybe I don't use it every day, but I didn't know that at the time. And it ended up turning out that it would have been extremely useful for me. Who knew I was going to become a writer about physics? I didn't. I didn't even know science writing existed. The same goes for you. So my plea to the young people, is not to cut off your choices that early. Learn the math, do the math, make us do the math, because that is what gives us choice. And then later on, if you don't want to learn anymore, that's great. But at least you'll be making a choice, and you won't be having that choice being made for you. And this is where I go do the shameless self-promotion. I do have a book. It's called The Calculus Diaries. A lot of the stuff that you saw earlier on is detailed in the chapters. At this point, I want to just open it up for questions, because I think the most interesting thing about talking to these audiences is having a dialogue.
My question is, in calculus, do you see the world as cause and effect, and for every action there's an equal and opposite reaction? Do you see it in that way?
Are you asking if I see it in a more reductive way?
Yes.
Yes, I think I probably do. It gets complicated because, obviously it's not as simple as Newtonian. There's a lot more math than just Newtonian, equal and opposite reaction. And particularly, I think when you're talking about biological systems, the mathematics gets incredibly complicated. You've got so many variables. There's such a thing as called nonlinear systems, which are almost very, very difficult to model because there's so many variables and they're all interdependent and they're all interacting. So at that point, the math gets very, very complicated. But I think fundamentally, we are still talking, about something that is governed by these things that are happening below the surface. We have this notion of emergence, that the sum is greater than the parts, that you can have, and you see this, say, in ants. A single ant might not be able to make a difference, but when they get all of them collectively, this other property emerges and they end up acting as one. You can pour them like a fluid. They actually start acting a little bit like a solid or a fluid. Those sorts of things are a little bit more how I like to think about math, because I like my math messy. My husband's a physicist. He likes his math clean and neat. He wants to know the underlying problem. There's room for both, and they are not mutually exclusive. They're just two different ways of describing systems.
Okay, thank you. And another question, Barbara?
Is it possible to tell in our solar system, the way it is now, where we have the center of gravity, at which point will all these planets be aligned in one straight line, and would that change our center of gravity to cause any tidal waves?
Well, I'm not a cosmologist, but no. My husband is. I think that you're thinking of that rare planetary alignment. I can't pronounce it. It's called syzygy or something like that. There was an X-Files episode about that. No, it does not. I mean, we have this idea that it should, but in fact, it's a much more complicated system than that. Again, this is where the complicated dynamics, and the math comes in. It's not just one or two planets. It's not just those 7 planets. There's all kinds of things that are happening. They're all moving. It really does not. People have actually looked into that, and I can tell you with great confidence that that is not going to happen.
I have a question. I was recently in a debate. You mentioned that mathematics, kids should take mathematics. Here in Ontario, students will take math all the way through to grade 12. In science, they can stop at grade 10. You have obviously a close relationship with the way the science works. Would you make the same argument for science and maybe pushing it further up? Or?
Yes, I can't imagine stopping at 10, particularly since I don't think calculus makes sense without physics to a lot of students. I think there's a certain kind of mind, these algebraic thinkers, the abstract thinkers that, that there's a small subset of the population that for whom algebra and calculus and math makes perfect sense. They have this wonderful intuitive grasp of it. I am not that person. And I talked to a lot of people who said, I actually was totally confused by calculus, and then I took physics, and suddenly it all started, I had a context, and suddenly it started clicking into place. And then because I had used it to solve some problems, I began to really appreciate the abstraction a bit more. So I'm also not a big fan, again, of this either-or, this idea that you don't have to take something. You should want to take something because it's enriching. We don't have to take art. We don't have to learn, music. I played the piano for a very long time, and I would spend hours on scales and wonder why I was doing them. And then I realized it was so that I might one day play Chopin, because those scales ended up getting incorporated into these wonderful, beautiful pieces that are timeless. Same thing for math, same thing for science.
Hi, I wanted to ask you your opinion on or your view on the relationship between language and mathematics, because the older I've gotten, and my buddy and myself, we haven't had a background in physics ourselves, but one of the things I've noticed over time is that the relationship between language and mathematics, to my mind, is just another type of language. Mm-hmm. And I think that if we sold mathematics as an alternate way or a more efficient way of communicating, there might be greater uptake. But I wonder what your views are as a science and math writer.
Well, I certainly approached it as a language. I mean, Galileo had this famous quotation that, the language of nature, is mathematics. It's written in mathematics. That is certainly how physicists understand nature, how they look at the world around them. It's not an accident that I mentioned the guy that invented algebra, that originally algebra was, in fact, words. That was a huge thing for me when I realized that they were words. And because I get words. I do have an intuitive sense of syntax and sentence structure and things like that, of grammar. And once I started thinking of it that way, then it became just these rules. Maybe they didn't come as easily to me. Maybe it wasn't quite as intuitive as language was, but I also use language more. And I found that the more I did my calculus problems, the easier a derivative or integral became. I started becoming more comfortable with that language. It's the use it or lose it model. You know, you kind of got to do the immersion thing, and you've got to do it at a fairly young age if you really want to be fluent. I would say that I'm really not fluent in calculus, but I can get by. I can order off the menu. You know, I can find my way around Paris.
Yeah, hi. Not to stir the pot too much, but I was wondering if you could address the sort of the I suppose the culture or the politics behind what you said earlier about students saying, I'm never going to use it, so why should I learn it? Mm-hmm. This very utilitarian attitude is a problem not just for math and physics, but in fact for a whole host of disciplines on both sides of the arts and science divide. And I'm wondering if you could address what does seem to be an increasing emphasis on this kind of dry utilitarianism where, you know, if I can't use it for anything, if I can't get a job, what's the point of studying it?
Well, I don't think this is new. I do think it's unfortunate. If you look at, you know, the American educational system is actually very good at teaching very fundamental basics of, you know, literacy. You can argue that point, you know, because we want them to be even more literate, but in fact, if you look back to like the 1700s in America, very few people could read and write, and now most people can. Not everyone. We still have a problem with illiteracy, and they might not do it well, you know, but they nonetheless do have some basics. But it is a utilitarian kind of a factory model, and I think that, and I agree with you. I mean, that's one of the reasons that I, you know, brought up the notion of, you know, why we study art, why we study music, why we have these things. If your only question is, when am I ever going to use this, you are asking the wrong question. And that definitely is what I was trying to get across. That's why I phrased it in terms of making it about choice, because I think that's something people can understand. You can appeal to their altruism all you want, but the fact is most people are pretty pragmatic, and many people do not have the luxury of studying things purely for their aesthetic value. I consider myself extremely fortunate that I have a career that allows me to think about and write about these things and talk to scientists and spend my time on this rather than having to worry about where the next, you know, meal is coming from. You know, the average person, single mom who's like waiting tables on double shift, or a college student who's like trying to work to pay off student loans, this is a reality. And oftentimes the aesthetics and the altruism gets lost, and I think we need a little bit of compassion on that. On the flip side, when we're talking about the infrastructure, yes, it is far too utilitarian. We definitely are very test score oriented. We want to measure everything, and we have metrics, and our metrics are our test scores, and that may or may not be a good indication of whether students are learning. I got great scores. That didn't mean I was good at it. That meant I understood what I was doing. It meant that I was really good at gaming the system. So I think we really kind of need to be careful of that as well. So, I mean, I'm kind of rambling here a bit because it's a complicated question. I mean, I understand what you're saying, and I agree that we should study these things for themselves, and that there is value in that, and that it is definitely wrong, particularly when it comes to higher education, to solely focus on utilitarianism. But I think we also have to recognize that most people don't have that luxury.
Thank you. That's a wonderful way to finish. Ladies and gentlemen, let's thank Jennifer Ouellette. Thank you.